Well, let me get the other recorder going here. There we go. Okay, let's look at this section. This is phase shift, sinusoidal curve fitting. We're just going to look at the phase shift portion, though. And let's look at this with an example. We got y is equal to 3 sine of 4x minus pi. And whenever you have a number inside with the x, it shifts left or right. It's opposite what you think. But before you'd have to do that on these, what you have to do is you have to factor out the numbers in front of your x. So first step is we're going to factor out to 4. Now when you factor it out, factor means divide out. We're going to divide this number by 4, so that's why we got pi over 4. Okay, now that we've done this, we're going to look at this. So this is going to shift it left to right, opposite of what you think, unless you think backwards. The negative pi over 4 would make us think goes left pi over 4, so it's really going to go right pi over 4. Now we're going to graph y is equal to 3 sine of 4x. So we ignore that negative pi over 4. And then once we get our graph, we're going to shift the entire thing right pi over 4 places. So let's take a look at this graph. Well, our amplitude is the absolute value of 3, which is 3. So it's going to bounce back and forth from negative 3 to 3. Sorry about that. And our period is going to equal to 2 pi over b. Well, b is the number that's before our x, which is 4. So this will be 2 pi over 4, or pi over 2. So let's build our t-chart here. We're always going to start with 0. This clear down here is always pi, or a period. Sorry. This is 1/2 of our period, which would be pi over 4. And this is 1/4 of our period, which would be pi over 8. Now it goes from 0 to pi over 8, 2 pi over 8, 3 pi over 8. And this is 3/4 of our period. Okay, so I'll plug that 0 into each one of these. So I got 3 sine of 4 times 0. Gives us 3 sine of 0. This one we got 3 sine of 4 times pi over 8, which gives us 3 sine of pi over 2. This one is 3 sine of 4 times pi over 4, which is 3 sine of pi. This one is 3 sine of 4 times 3 pi over 8, which is 3 sine of 3 pi over 2. And this one is 3 sine of 4 times pi over 2, which gives us 3 sine of 2 pi. Well, here's my unit circle. Here's 0. Actually, let me go ahead and put the points. This would be 1, 0. This point up here would be 0, 1. This one is negative 1, 0. And this one is 0, negative 1. Sine is our y on our unit circle. So here I'm at 0. Y is 0. So this is going to be 3 times 0, or 0. I'm up here at pi over 2. Sine is our y, which is 1. So I got 3 times 1, which is 3. I'm over here to pi. Sine is our y, which is 0. So I got 3 times 0, which is 0. I'm down here at 3 pi over 2. Sine is negative 1. So I have 3 times negative 1, which is negative 3. And I'm back to 0 here. Because remember, it's periodic, so it repeats. Okay, let's plot these points. Now I'm going to shift it right pi over 4 places, so keep that in mind. Okay, I'm just kind of getting the visual here. This is going from 0 to like 1.5 and going up 3 and negative 3. Okay. So I'll say that's 3 there. And that'll be negative 3 there. Okay, and then it's going to pi over 2. Well, this distance is about, there's 3, and that's about pi. Pi over 2 would be half of that. Should be that right there. Then this would be pi over 4 here. Now that distance is pi over 4, so that's pi over 4, 2 pi over 4, or pi over 2. And this would be 3 pi over 4. We'll come back to that. Okay, let's plot our points. Okay, so our first one is 0, 0, which is that right there. Our next one is pi over 8, 3. Well, I didn't put the tick marks here, but pi over 8 would be here, and this is 3 pi over 8. So pi over 8 and 3. We're right there. Then we had pi over 4 and 0. And then we had 3 pi over 8 and negative 3. And then we had pi over 2 and 0. Now, knowing what this graph looks like, we kind of sketch it. Okay, so it's going to go up like that, come down like that. Of course, I don't draw it real well, but and then remember our shift. We then want to shift the entire thing right pi over 4. Well, pi over 4 is 2 of these tick marks. So I'll take each point, move them over. I'll start with this one, I guess. Move it over to there. This one moves over to here. This one moves over to here. This one moves over 2 of them, which should be right there. And the one down here moves over 2, which would be right there. So then I connect these together, trying to make it look like like our sine curve. And that's basically our answer. Now, if it says for 2 periods, then we would repeat it over. Show at least 2 periods. Let me try to roughly sketch it. And back to our starting place. Okay, that'd be 2 periods. And again, I didn't do little tick marks here, but you get the idea. Now, let me save this. That's interesting. There. And let's look at our second problem. This one here. Okay. So we've got y is equal to negative 2 cosine, and we got 3x minus pi over 2. Again, before we can decide which way it's shifting, left or right, and how much, is we need to factor out the numbers in front of the x, which is a 3. So I'll factor that out, and this becomes pi over 6. Now, if you can't see that, what I did is I took pi over 2, and I divided by 3. Because I'm factoring out a 3, which means I'm dividing out a 3. Well, if I want to divide fractions, they both should be fractions. So put 3 over 1, rewrite it as multiplication, and we flip a second fraction, take a reciprocal of it to do that, and that's where we get the pi over 6. Which means that when all is said and done, this is negative, so negative makes me think to the left, so it's really going to be right, pi over 6. Now what we're going to graph, we're going to ignore that, and we're going to graph y is equal to negative 2 cosine of 3x. Okay, now our amplitude is the absolute value of a, which is the absolute value of negative 2, which is 2. And our period will be 2 pi over b, and b in this case is 3. Okay, so this is always 0. Our last one here is always our period. So that's 2 pi over 3. Middle here is 1/2 of our period. Well, if I take 1/2 times this, the 2's would cancel, and I'd have pi over 3. 1/4 of our period, if I take 1/4 times this, I'd get pi over 6. Yeah. Now this is going from 0 to pi over 6. I'm added pi over 6. I add another pi over 6, and I get 2 pi over 6, or pi over 3. Then I have 3 pi over 6, which is, what, pi over 2? We can also use 3/4 times our period to get that. Okay, so let's plug this in. So I got negative 2 cosine of 3 times 0, which gives us negative 2 cosine of 0. This one we got negative 2 cosine of 3 times pi over 6, which is negative 2 cosine of pi over 2. This one is negative 2 cosine of 3 times pi over 3 equals negative 2 cosine of pi. And this one is negative 2 cosine of 3 times pi over 2, which is negative 2 cosine of 3 pi over 2. And this one is negative 2 cosine, and I'm showing all these steps, but we know what they're all going to give us. They all go back to these. 0, pi over 2, pi, 3 pi over 2, and 2 pi. I'm just going through the motions here to really demonstrate that. Okay, here's our unit circle. Here's our starting place. So we got cosine is 0. Remember, cosine is our x part. Well, x is 1 here. So we got negative 2 times 1, which gives us negative 2. Cosine of pi over 2. So I'm up here. Cosine is our x part, which is 0 there. So that gives us 0. We're over to here. Cosine of pi is negative 1. So we got negative 2 times negative 1, which gives us a positive 2. Now I'm to cosine 3 pi over 2, which is here, and x is 0 there. So negative 2 times 0 is 0. And I'm back to here, which would be back to 1. So this is back to negative 2. Okay, now let me see. Pi is roughly 3. So if I put 3 in for pi, the 3's would cancel, so this would be 2. So that's approximately that 2. And then these are 2's also. Well, okay, that works out decent. Okay, so if this distance here is 2 pi over 3, which is approximately 2, then this distance here should match the distance right here for 2, more or less. And that'd be negative 2. Here in the middle is our pi over 3. This one would be pi over 6, 2 pi over 6, 3 pi over 6, or pi over, what did I say, half? Let me look. Yeah. First one is 0, negative 2. It should be right there. Next one would be pi over 6, 0, which is right there. Next one should be pi over 3 and 2. Next one should be pi over 2 and 0, and then 2 pi over 3 and negative 2. Now if I roughly draw this, Ah, right away I didn't get the proper angle. Use your imagination. It's a lot smoother than this. Okay, we got that there. Well, way up here we said that when we get all said and done, we want to shift it pi over 6 to the right. Well, pi over 6 is one of these little tick marks. So this point moving over would be right there. This point moving over would be right there. This point moving over would be right there. This one would be right there. And this one would be approximately right there. So connect those together. Now it's supposed to be for 2 periods. So if I kept on going, okay, there's 1, and then down to here would be our 2. Now I'm not going to put a lot of effort in doing tick marks here. I'm happy on the work if you just do this fairly accurate, and then just eyeball that. Okay, let me go ahead and save that. Then we'll look at our last example. Okay, so we got y is equal to 5 sine of pi x minus 3 minus 2. Now again, before we determine anything, we want to factor out the number that's in front of our x, which is pi, and that'll leave us x minus 3 over pi. Okay, so when this is all said and done, this is going to shift left or right, opposite what you think. It says negative, so we think negative to the left, so it's really going to be right. So it's going to be right 3 over pi. Now, pi is 3.14, a bunch of decimal places, approximately 3. So this is approximately 1. So this is just sketching. So once we get done, we're going to shift it 1 unit to the right. Now here at the end, this negative 2, that means we're going to go down 2. So we're going to ignore those for the time being, and we're going to go ahead and just graph y is equal to 5 sine of pi x. So let's get that graph, and then we'll shift it down to right 1. Not that we use the amplitude a whole lot, but it's the absolute value of a, which is absolute value of 5, which is 5. And our period is 2 pi over b, and b is numbers for x, which is pi. So I got 2 pi over pi, or 2. So we'll do our x and y values. This first one is always 0. This last one is always our period, which is 2. This is half our period, which is 1. This is quarter of our period, which is 1/2. And this is 3/4 of our period, which would be 3/2. And we're going to be plugging into this. Y is equal to 5 sine pi over x. Okay, so I'm going to have 5 sine pi times 0. So that gives us 5 sine of 0. Then we're going to have 5 sine of pi times 1/2, which is going to give us 5 sine of pi over 2. And we'll have 5 sine of pi times 1, which gives us 5 sine of pi. This one will be 5 sine of pi times 3/2. Gives us 5 sine of 3 pi over 2. This one gives us 5 sine of pi times 2, which is 5 sine of 2 pi. Okay, here's our unit circle. Again, the only ones we're interested in is these major ones. Those are always 1, 0, 0, 1, negative 1, 0. So those. Sine is our y part. So here I am at 0. My y part here is 0. So I got 5 times 0, or 0. Pi over 2. Sine had become 1. So 5 times 1, which is 5. Over here at pi, sine is back down to 0. Down here at 3 pi over 2, y is equal to negative 1. So this becomes negative 5. And then this will be back to 0. So, okay, so our period is 2, and then this goes up to 5, negative 5, and we want to move it down 2. Okay, so do a little bit of planning here. So that'd be 5. And then this would be like 1, 2, 3, 4. And negative 1, negative 2, negative 3, negative 4. And negative 5. And we set up above, we're going to shift it down 2. So I definitely need to have it go down to negative 7. Okay. Okay, so now our period is 2. So let me come over here. 2 is a distance from here to here. So this has to be a distance of 2. Then this would be 1, this would be 1/2, and this would be 3/2. So let's well, let me try that one again. There we go. There. Okay, so our first point is 0, 0. That. Our next one will be 1/2, 5. To be right up there. The next one should be back down to here. This one should be down to negative 5. Then this one should be back to here. Okay, let me sketch that roughly. Okay, looks like this. Use your imagination. Those are nice and smooth and looks like the sine graph. And then we're going to shift it right 1, down 2. So we're going to go right 1 and down 2. Okay. So move this this point here, right 1, down 2. That'd be right there. This one, move it right 1, down 2. That'd be right there. This one, right 1, down 2. Okay, I got something screwed up. Let's try that again. Eyes got off. Right 1. Okay, this is it there, so it'd be right here. Down 2 would be right there. And this one would be one more over and down 2, right there. So right 1, down 2. Okay. And of course this one would be right 1, down 2, so it'll be even with those. Notice how all three of those are lined up. Then this one will be halfway in between here and down 2, which would be right here. Okay. Then I'll kind of draw them together here. Use your imagination. These are nice and smooth and looks like the sine curve. And that would be our graph shifted. And again, to repeat it, I would repeat that pattern over. But that would be this graph right here. So let me go ahead and save that. stop the recorder. Actually, let me clear that. And then stop this recorder.